Hello everyone and welcome back to Novel for GCSE. So welcome to the chemistry session. This is going to last 2 hours and we're going to first look over paper 1 and then we're going to look over paper 2. So someone had asked what topics are we going to look over in this. So we're going to be looking at all of the topics, as many as we can, doing some broad questions, revising each of them. So we're going to begin with looking at a bit about bonding and structure. So on this Google document, I'm going to put all of the questions and then the answers I will work through with you. So the first question is, explain why metals can be shaped. Now this would be roughly 2 marks. So let's look into explaining why metals can be shaped. So firstly, we need to talk about the properties of metals. So metals are made up of layers. That's the first keyword you need to put. Metals are made of layers. And these layers are regular. They're regular and they all have the same size. So regular in size and shape. Now we're asked, explain why metals can be shaped. So what we'll discuss is the fact that these metal layers can slide. And because these layers can slide over each other, this then means that it can be malleable. So that's how we would answer this question. For those of you who have just joined, feel free to put your answers in the chat below. The next question. So the next question, again, still about bonding and structure. So, why is graphite used in pencils? Okay, so let's go on to why is graphite used in pencils. So graphite is an example of a covalent bond, of a simple covalent bond. And graphite, like metals, have layers that can slide. Okay, feel free to put in the comments why you think graphite can be used in pencils. So first of all, graphite has layers that can slide. And the reason why they can slide is because there's no bonds in between the layers. So remember, graphite is the hexagonal structure, the giant covalent bond where we only have a hexagonal structure. So each carbon atom only forms 3 bonds. However, we know from the diamond structure that carbon, to be fully reactive, can form 4 bonds. This then means that there will be an extra electron in between, which means that they can conduct electricity, but also there's no bonds between the layers, which means that they can slide. Therefore, graphite can rub on paper. Okay, let's move on to the next question. So, compare alloys to metals, why are alloys hard? So let's compare alloys and metals now. So alloys and metals, first of all, let's identify what they are. We know that alloys are a mixture of different metals in order to increase the strength of a metal. So what we have here is when we have a metallic structure, we have regular atoms in regular sizes and regular shapes, and they're in layers, and we know that these layers can slide because that's how metals can be malleable. Now with alloys, there are atoms of different elements. Now because they're atoms of different elements, this means that they have different sizes and they're squished in to this structure. So this structure is what we call a disrupted structure. Is fragmented because there's atoms of different types and different sizes all pushed and squished together, meaning that it can't slide because there's no layers, and therefore it's harder and not malleable or less malleable. Now another thing, because we're comparing alloys with metals also have delocalized electrons. Now if we were to explain why metals can conduct electricity, what we would say is the negative nature of the delocalized electrons and the positive nature of the metal ions then explains the strength of a metal, and the delocalized electrons can carry electricity and charge. Now let's look at the next question, which is about nanotechnology. So, evaluate the use of nanotechnology. So this is coming to the end of the first part of the chemistry topic, so we are doing really well on time here. So evaluate the use of nanotechnology. Well, when we're saying evaluate, what we have to say is we have to say the good parts of it, the bad parts of it, and then we can give a conclusion of ourselves, like I believe. So the good parts of nanotechnology is that it can be used in medicine, it can be used in communications, and nanotechnology can be used in electronics. Now, the bad parts of nanotechnology are things like people are unsure of the side effects. So people are firstly hesitant to use, and then secondly, people are unsure of the side effects. And then you can give your opinion right at the end and say, I think that the nanotechnology is good or bad because. Now, the next question is linked to this. So, explain why carbon nanotubes conduct electricity. So now we're being asked about carbon nanotubes, and that's part of nanotechnology, so that's really important. So let's go over carbon nanotubes now. So how can carbon nanotubes conduct electricity? Well, in order for anything to conduct electricity, you're going to need delocalized electrons, no matter what. Delocalized electrons are essential for conducting electricity because they're free to carry the charge. And so if we're explaining why carbon nanotubes conduct electricity, you can say firstly they contain delocalized electrons, and then you can say secondly, talk about the purpose of it, therefore the electrons can move through the structure and carry charge. Okay, now let's move on to the next question. Suggest one reason why the C70 molecule is used for medicine. So when we say C70, this is talking about the Buckminster fullerenes, and which is the hollow structures that carbons can form. And it all comes from this idea of graphene, which is a single layer of carbon. Now, what we're saying here is talking about how this C70 molecule can be used for medicine. So first of all, we know that these molecules are 3D hollow shapes. Now, for medicine, what the use is that we can put medicine inside of these 3D hollow shapes and can then transport it into the body. So you'll say the hollow shapes, as well as you can say the large surface area, enables the drugs to be transported by trapping them. And that's all you would have to say. Now let's return a bit back to graphite. So explain why graphite is a good electrical conductor and is soft and slippery. Now this would be like a 4 marker or a 6 marker because it's asking you for a lot. It wants to know not only why can graphite conduct electricity, but also some other properties explanations such as why is it soft and why is it slippery. So when answering this question, let's break it down into being an electrical conductor and then being soft and slippery. Now, the more you can break down a 6 marker for any of the sciences, the better it is, because then the more you're getting common points to answer the mark scheme with. So the reason why it's a good electrical conductor is because graphite only contains 3 carbon bonds. Because it only contains 3 carbon bonds, this means that there are delocalized electrons. And delocalized electrons can move through the structure and carry charge. Now, if we were to explain why is it soft and slippery? So in terms of why it's soft and slippery, you could say because there's the 3 carbon bonds, the 3 carbon bonds are formed in hexagonal rings, which means that there are no bonds between the layers. And because there are no bonds between the layers, this then means that it's soft and slippery and can slide on the paper or whatever you're using to write with. Now, a better way to put the no bonds between the layers, you can also put no bonds between the layers, which causes weak intermolecular forces. Now, just with these 6 points here, you can definitely get 6 marks from this. Now let's do a practical style question. So this question is about a practical. Describe a method to find the position of an unknown metal in the reactivity series. Your method should give valid results. Okay, so you have to find a method to find the position of something within the reactivity series. So this requires you to exhibit your knowledge on the reactivity series. So let's see what you know. So first, let's talk about the reactivity series. The reactivity series is a group of metals ordered in the format of their reactivity. So the most reactive is at the top and the least reactive is at the bottom. So there's a couple of approaches you can do with this question. There's 4 different approaches. So I'm going to just choose and talk about 2. So let's talk about approach number 1. So approach 1 with this question would be add the unknown metal to copper sulfate. And then measure the temperature change. So you're reacting the metal with the copper sulfate and you're measuring the temperature change. And then you're going to place the metals in order of temperature change. So the ones with the greatest temperature change means that they have reacted the most. Okay, so that's approach 1. This is reacting it with copper sulfate and seeing what will happen there. Let's talk about approach 2. Approach 2, what you could have done is you could have added the metal to a salt solution of the other metals, or you can heat the metal with oxides of the other metal. So you do metal plus salt of the other metal, and then you can measure the temperature change again. So temperature change would be a viable method for both of these. Okay. And then any other methods you could do, you could add all of the metals to an acid and measure the temperature change, or you can set up an electrochemical cell and basically the electrolysis. So one metal will be as one electrode and the other will be as the other electrode, so the cathode and the anode, and then you're going to measure the voltage of the cell and then place them in order of the voltages. So those are the different approaches. Let's then move on to the next question, which is again another practical question. Describe a method for making crystals of potassium chloride from potassium hydroxide and hydrochloric acid. So let's break this question down a bit. We've got a method for making crystals, which in another word is just salt. So how to make salt from potassium chloride, which is going to be the acid, and then potassium hydroxide. Potassium chloride is a salt, potassium hydroxide is the alkali, and hydrochloric acid is the acid. So let's answer this. Okay, so let's talk about this practical. So firstly, this is all about titrations. So firstly, you want to pour a known volume of potassium hydroxide into the beaker, into the conical flasks. Sorry. I think it'll be best to draw this out. So we have the conical flask here, which is now full of a specific volume that you've recorded of potassium hydroxide. Okay, so now we have the potassium hydroxide. We're going to use a large pipette filler to extract hydrochloric acid and then put it into the burette. So we have another piece of equipment now called the burette, which is going to be held up by a clamp, a standing clamp. So this is burette, and within the burette, we've got a little tap here, which will allow us to slowly add the acid to the alkali. Now, we need to then put the acid into the burette, and in order to put the acid into the burette, we're going to use this thing called a large pipette filler. And therefore, the acid is going to go there. Now, you can put any volume of acid because that's what we're measuring. So in terms of the independent variable, what we're changing the amount of acid we're adding into it. Dependent variable is we're measuring the amount of acid needed. So you put the acid through the burette, you then put the conical flask underneath the clamp, you slowly add the tap, also add the indicator phenolphthalein. This turns the solution pink, and then when there's enough acid, a neutralization reaction will occur, and therefore it will turn from green from pink back to the neutral tones, so clear, pink to clear, as the acid comes and just enough acid comes. So that's the titration required practical. But you're not just asked for this, you're asked, how do you get potassium chloride crystals? So once you've reacted the potassium hydroxide with the hydrochloric acid, you'll then get, in your conical flask, potassium chloride. We want crystals of potassium chloride. Now, in order to get crystals, you then have to either undo crystallization or evaporation. Now, both of them involve heating it on a tripod stand. You've got your Bunsen burner there, and you have your heatproof mat underneath, and then you have your conical flask. But then you don't just put the conical flask above it, so you clearly put the conical flask, convert the potassium chloride into a crucible, and you put the crucible on top of the heater. Now, the difference between crystallization and evaporation is that with crystallization, you stop heating once you see crystals start to form. And the reason why you stop heating is because the solution breaks down with heat. So in order to prevent it from breaking down, you stop heating and then you put the crucible on the side to evaporate the rest by itself. Whereas evaporation is just constant heating until all you have left is just the crystals. An advantage with crystallization is that you actually get better crystals because it's more sustained over a long period of time. Okay, so let's now move on to the next question, which is again about titration. So it's a secondary question about this required practical. So feel free to answer this in the chat. Explain why the student should use a pipette to measure the dilute sulfuric acid and a burette to measure the sodium hydroxide solution. So we have to explain why a pipette would be used for the acid and the burette will be used for the hydrochloric acid solution. So let's answer this now. Pipette, burette. So a pipette measures a fixed volume. Whereas a burette measures a variable volume. So we're being asked, why would the pipette be used to measure the acid and the burette to measure the alkali? Well, then that tells you that the person is trying to find the amount of alkali needed to neutralize a fixed volume of acid. And that's really important. Now let's move on to the electrolysis required practical. So we're 23 minutes in and we're doing really well for timings. So just keep going and keep continuing. So the next question, as I said, is about electrolysis. Electrolysis is often viewed as a hard topic, so don't get too frightened at the sign of the name. Required practical for electrolysis. So let's look at the required practical for electrolysis. So let's begin with a beaker. Everything is nice when we begin with a beaker. So we have a nice little beaker here. Now, within this beaker, we need to add the electrolyte. Right? The electrolyte is what you have in a solution that's ions move to the electrodes. So this is called the electrolyte. An electrolyte must be an ionic aqueous solution. So in this case, the electrolysis would be 50 centimeters cubed of copper chloride. Now what we're going to do, so after we've added 50 centimeters cubed of copper chloride, now just so you know, the copper part are the metal ions. So the metal ions will be attracted to the negative electrode because it has formed a positive ion and it will gain its electrons back. Now the chlorine is a non-metal, and the non-metal will therefore want to go to the positive so that it can release the electrons that it's gained. Okay, so we have our electrolyte here. Let's represent the electrolyte with a blue liquid. Okay, now we're going to have our two electrons in the solution. One is one is going to be positive and one is going to be negative. Now, we have to connect the electrodes to a power source because the ions will only move within the solution if there's a power source available to make this positive charge and to make this negative. So if we connect this to a power source, this can be viewed as a power pack, like that. Let me just label that power pack. Okay, so now we have the power pack. Now, because we're using a beaker, we are going to add a specialist type of lid, and this lid basically holds the positive electrode and holds the negative electrode, because we don't want the electrodes touching the bottom, because it would mean that not enough ions will be able to move across. So we have the positive and negative electrode. Now, make sure that you have a low voltage supply. We don't want a very high voltage supply because the reaction will be too quick for us to talk about the different things that we can see, like whether there's oxygen being made or things like that. You're then going to use some forceps which can hold the litmus paper near the positive electrode. So you have a positive electrode here, and we're going to hold some litmus paper. Now, the reason why we're holding litmus paper is because we want to see the product of the electrolysis reaction. Okay, so let's talk about what happens at each of the electrodes. So we have the positive electrode here and the negative electrode here. So what happens at each one when we have copper chloride? So at the positive electrode, what happens is we see the chlorine go to the positive electrode, and as we said, we see the metal come to the negative, which in this case was copper. So we see the metal go to the copper, the metal go to the negative, and the chlorine go to the positive. So we see the non-metals go to the positive, metals go to the negative. Now, what does the chlorine do here? So the reason why we held this litmus paper by the positive electrode is because chlorine can bleach litmus paper white. So chlorine would bleach the litmus paper white. So therefore, if held litmus paper by the positive electrode, we will then know that chlorine has been made at the positive electrode. Now, another thing that we can observe is the fact that there will be bubbles here, because it will be chlorine gas that is made, and therefore there will be bubbles. And another thing is chlorine gas, so you may be able to smell the smell of chlorine. So that's what you'll see at the positive electrode. Now at the negative electrode, we'll see the metal copper. Now the copper is trying to get back its electrons that it lost to form an element again. Now what you'll see is that the copper will form a brown coating on the electrode. So if you start to see a bit of brown coating form by the negative electrode, then you know that the copper is there. Now let's just show you another example of electrolysis with sodium chloride, because sodium chloride is often used in exam questions as an example. So when we have sodium chloride and we have the positive electrode and the negative electrode. So at the positive electrode, we'll see the chlorine. And as we said, we see chlorine bubbles. It also bleaches litmus paper. Now at the negative electrode, we're going to see the sodium. Now, because it's electrolysis of an aqueous solution, for sodium it's a bit different here. So instead of getting a coating of sodium, instead you're going to get bubbles of oxygen as well as hydrogen gas. Now, if you're unsure about why there would be bubbles of oxygen and hydrogen gas at the negative electrode, then you need to do some revision over electrolysis in aqueous solutions. But if you do know, then fair enough, and we can move on. Okay, let's do the next question now, which is an explain how question. Explain what happens at each electrode during the electrolysis of aluminium oxide. So this would be a 4-marker, explaining what happens at each electrode during the electrolysis of aluminium oxide. So aluminium oxide is often used for an electrolysis example. So let's deep dive into that now. Also, if you do have any ideas, feel free to put them in the chat because I can definitely read them as well. So, aluminium oxide. We have to talk about each stage of electrolysis. So, this means we have to talk about what happens at the negative electrode and what happens at the positive electrode. Now remember our rules. So we said that the metal always goes to the negative. So metal goes to the negative. And in this case, what is the metal? Aluminium. And then what happens at the positive? The non-metal goes to the positive. And the positive here is oxygen. Now we have to talk about the half equations here. So half equations, or the ionic equations, just talk about the key ions here. So aluminium oxide, the formula is Al3O2. That's the formula for aluminium oxide, because 3 electrons from aluminium is given to 2 oxygens. So at the negative electrode, what happens is we want to go from Al3 back to just Al. What does this mean then? Al3 plus means that we need 3 electrons for aluminium. And to get 3 electrons for aluminium, you then have to do this equation. Al3 plus 3E minus, because you're adding the electrons, and as you can see here, when you're adding 3 electrons to something that is short of 3 electrons, you then just get the pure metal. So that would be the equation at the negative electrode. Now at the positive electrode, we have O2. Now oxygen, being the non-metal, forms a negative 2 charge. Now for oxygen, we want to get back to just O2. So you want to get rid of these 2 electrons that we have gained. Now in order to get rid of these 2 electrons, we just have to separate them like this. And that's what would happen. So the positive electrode, you have your oxygen, and then it forms oxygen, but without the 2e minus charge. Now, this is what we call oxidation, because it's reacting with oxygen. The electrode is carbon, and it then... So you may be asked, another question may be asked is, why should carbon electrodes not be used? Carbon electrodes, and specifically carbon positive electrodes. Now, the reason why carbon shouldn't be used is because here you can see we have oxygen, and here we have carbon. So therefore, as it attracts this, it forms carbon dioxide gas, and then it floats and wears away really easily, as well as the fact that carbon dioxide is not really good for our atmosphere. That's why we warn against using carbon electrodes. Okay, let's move on to a little bit more. So the next question is, explain why a mixture is used as the electrolyte instead of using aluminium oxide. So what it's saying here is, when we have our beaker, for the electrolyte, you normally just put the melted version of whatever you're trying to separate. So if you're trying to separate sodium chloride, you just put the molten version of it in the liquid. However, in this question, they said that they didn't use the aluminium oxide melted version. Instead, they used a mixture. And they're asking, why did they choose to use a mixture instead of just the melted aluminium oxide? Now, normally, when they use a mixture instead of just melting it, it's normally because the melting point of whatever solution, which in this case is aluminium oxide, is too high. And because it's too high, it's then mixed with something. Now, in this case, it's called cryolite. So the substance it's mixed with is called cryolite. So aluminium, because its melting point is so high, it's mixed with a substance called cryolite, which then reduces the melting point. And because it reduces the melting point, it reduces the amount of energy required to heat up the solution and separate them. And therefore, if reducing the amount of energy required, you're reducing the costs and things like that. So in this case, cryolite works as a catalyst because it reduces the amount of energy required so that the reaction can take place much more quickly. Now we're going to talk about acids and alkalis. Much more nicer topic as opposed to this. So let's do the next question. It's all about acids and alkalis. These are the questions we've gone through so far. What are the differences between strong acids and weak acids? So this is our next question, and it has been asked 2 years in a row. So be aware of this question. What is the difference between strong acids and weak acids? Now, I need to tell you some key facts about acids and concentration and being strong or not being strong. So let me show you here now. So you need to know that the strength of an acid is not the same thing as the concentration of an acid. They're not the same thing. Now, what we mean by the strength of an acid is whether they fully ionize, so whether they fully release the ions needed. And whether they have their concentration, the concentration is how much acid there is in a particular volume. So it is possible to have a very strong acid that is diluted because of the fact that the strong acid fully ionizes but is put in a lot of water. So this is the amount of acid and this is the water. This talks about concentration. So the mass of something, which is the acid, over the volume it's put in. That's what concentration is. And the strength is how well it ionizes and whether it fully dissociates. Now, dissociates means, does it fully break down into H plus ions? Now, a weak acid is something that will only partially dissociate, which means a weak acid will not fully break down and can therefore be a reversible reaction, whereas a strong acid won't be. So let's bring our knowledge now that we've looked at back to the question. So the question itself was, what are the differences between a strong and a weak acid? You can just say a strong acid is an acid that fully dissociates. Now, what we mean by this is it's an acid that if you put it in water, the H plus ions will ionize. So if put in water, the H plus ions will ionize. And therefore, a weak acid is an acid that only partially dissociates. And therefore, if you put a weak acid in water, the H plus ions will not ionize. I hope that makes sense. If you have any more questions, feel free to put them in the chat so I know and I can stop and re-explain something for you. Let's move on to the next question. What is the difference between high and low concentrations of acids? So let's write that here. What is the difference between high and low concentrations of acids? Just so you know, everyone, I will be linking this document in the comments after this live stream is done, so you can access all of the questions that we're looking at now. So let's go back to this idea of what is the concentration, what is the difference between high and low concentrations of acids? Now, as we said, concentration is just a measure of the mass of something in a particular volume. Therefore, the concentrations of a highly concentrated substance in comparison to a lowly concentrated substance. So a highly concentrated acid just means that in a particular volume of, say, water, for example, we have high concentration. We have a lot of acid in comparison to the water. Whereas a low concentration of acid, also known as a dilute solution, has more water than acid, or more of the other substance than acid. So not much acid per volume. Okay, so that's concentration and strength. Now let's talk about the pH. Let's do a question on the pH. Explain why the pH of an acid depends on, the strength of the acid and the concentration of the acid. So this again links to the topics we just looked at, which is strength and concentration of acids. So we're being asked now, how does the pH depend on these two factors, the concentration and the strength? So let's look at that now. pH. So in general, the pH is just a measure of how many H plus ions there are. Now, in case you're wondering what are H plus ions, well, let's discuss them now. So when we have an acid and when we have an alkali, acids are H plus ions. Alkalis are OH minus ions. Now, believe it or not, when you react an acid with an alkali, you should know this, we form a neutral solution. So when we do acid plus alkali, we get a neutral solution, which is water. Therefore, when we're talking about H plus ions, we're basically saying how acidic is a substance. So the pH is, in one way, how acidic a substance is. Now, the higher the concentration of the H plus ions, the lower the pH. So just returning to the question, explain how it depends on the strength and the concentration. Let's talk about that now. So the pH, how many H plus ions there are, and the more H plus ions there are, then the lower the pH is. Now let's talk about how this relates to the strength, and let's discuss that now. So how does the pH relate to the strength? The stronger an acid is, the greater the ionization. Ionization is it becomes an ionic. So the greater the dissociation is another way of putting it in aqueous solutions. The stronger an acid is, the greater the ionization in aqueous solutions. So the stronger the acid, the lower the pH. So the stronger the acid, the lower the pH. So what we're doing here is we're linking the idea that the strength of an acid is all based on how the rates of the ionization are, and the greater the rates of the ionization, the lower the pH. So we're linking those three ideas. Now let's discuss the concentration. So as you said, the concentration of H plus ions. So what we're saying here is that the higher the concentration of an acid, this means that the more acidic there is the more acid molecules there are within the same volume of solution. So the higher the concentration, the lower the pH. And that's how we would answer that question. Okay, so let's do an example. Not an example, just using our knowledge that we've just looked at. So dilute hydrochloric acid is a strong acid. Explain why an acid can be described as both strong and dilute. So what you would say is, linking back to our strong notes about strength, the strength of an acid is dependent on whether its ionization, how strongly it ionizes. And the strength depends on the ionization. So hydrochloric acid can be strong because it fully ionizes and it fully dissociates. However, it can be dilute because there is a small amount of hydrochloric acid per volume. So the acid per volume is small. Now let's just go through another question, a little bit related to electrolysis. What is the difference between a chemical cell and an electrolyte? So this is linking to the topic of fuel cells and things like that. So what's the difference between a chemical cell and an electrolyte? So a chemical cell uses a chemical reaction to produce electricity. So let's look at this now. So a chemical cell uses a chemical reaction to produce energy. A chemical cell, so also known as a fuel cell, so things like the reaction of hydrogen and oxygen, it uses the chemical reaction to then produce energy. Now an electrolyte actually is very much the opposite. So an electrolyte uses electricity to produce a chemical reaction. And that is what's so ironic about this. A chemical cell uses a chemical reaction to produce energy, and an electrolyte uses electricity to produce energy and a chemical reaction. Now, finally, explain why the excess hydrogen must be burnt off in a hydrogen fuel cell. Now, this prevents hydrogen from escaping into the air because hydrogen is explosive. Now, let's finish this chemistry paper 1 topic up with some short 1 markers, which I will just dictate for you. So, the first one: how does the reaction profile show that the reaction is exothermic? So, this is all about reaction profile diagrams. So, this is basically like this for exothermic, and this just says how the level of products is below the level of reactants, which suggests it's exothermic. The next question: why do alkaline batteries eventually stop working? So alkaline batteries eventually stop working due to the fact that a single reactant is used up. Next question: so why can alkaline batteries not be charged? This is a simple answer: the reaction is not reversible. Complete the balanced equation for the overall reaction within a hydrogen fuel cell. So let's look at a hydrogen fuel cell reaction. The overall reaction is 2 hydrogen plus oxygen creates water. So this is the reaction within a hydrogen fuel cell. You have the hydrogen, you have the oxygen, and then you have the water. Now, in terms of just revising what happens in a hydrogen fuel cell, let's look at that. So within a hydrogen fuel cell, we have this massive container, this massive vat, and the hydrogen comes one way inside and the oxygen comes in the other. And what happens is we have the different electrodes. And the various electrodes do the various jobs and things that they need to do. So what that then means is that one will have to be positive and one will have to be negative. Now they're both gases, so they're both actually non-metals. However, one will be positive. So the oxygen will go through the positive and the hydrogen will go through the negative. They will then become the elements they are and then react again. So similar to an electrolysis reaction. Okay. Finally, give 2 advantages of using hydrogen fuel cells instead of using rechargeable batteries to power cars. So now we're comparing hydrogen fuel cells to alkaline batteries. So alkaline batteries, not alkaline batteries, rechargeable batteries. So rechargeable batteries require there's no toxic chemicals required in a rechargeable battery. So no toxic chemicals prevalent. On the other hand, in the hydrogen fuel cells, the hydrogen produced is actually explosive. So that's why the excess hydrogen needs to be disposed of. It can't just be released in the air. Now, another thing is that the hydrogen fuel cells actually take less time to refuel. because all you need to do is get more of the hydrogen and get more of the oxygen. Whereas rechargeable, you then have to charge it to get back that energy, and then you can start using it again. So this could be a 6 marker now, where you have to evaluate the use of hydrogen fuel cells in comparison with rechargeable lithium ion charge batteries. So we're comparing hydrogen with rechargeable. Now, in order for us to have a balanced argument, we have to have reasons for both sides. So, in order for reasons why fuel cells are better, you can say the time for refueling is much shorter, as it does not need to be recharged. And you can also say that a fuel cell has a greater range, which means it just produces a lot more energy in comparison to rechargeable batteries. However, rechargeable batteries actually uses energy more efficiently. And another good thing about rechargeable batteries is that the cost of recharging them is much less than refueling them. So the costs are much cheaper overall. And well done, we have gone through the whole of paper 1. I will, as I said, put the questions into the comments below so that you can have access to them, and if you want to rewatch them, because I know people like to rewatch these live streams. But we're now going to go on to paper 2. Oh, but just another thing before we move on, because I don't want you to be without any information. So, you will always be asked about these equations, which is for electrolysis. So, what happens at the different electrodes? So, your hydrogen becomes 2H plus 2E minus. So, it goes to the, because this forms currently, the hydrogen is an element, and then it takes away its 2 electrons to form a positive, and then oxygen reacts with hydrogen and 4E minus, so it gains 4 electrons as well as the hydrogen, and then creates 2 molecules of water. Okay, let's now move on to paper 2 for chemistry. So we've gone over paper 1 questions, let's go over paper 2. So paper 2 sets off already immediately into required practicals. So let's look at some questions for required practicals. So these were the questions for paper 1 chemistry. So now I'm going to move on to paper 2. Okay. And I'm going to just call this session required practicals, because we'll first be looking at the rates and extents of chemical change, because there's a lot of required practicals and things that they tend to ask you in here. So let me just share my board with you, and then we can go over the different parts to the required practical. So the overall required practical is called rates of reaction. Okay, rates of reaction, and there's different ways you can measure the rates of a reaction. In particular, there's 3 parts. So firstly, you can use the visual method. So let me just get access to the sheet 1 second. Sorry if you're waiting, I'm just trying to get the rates of the reaction sheet that I had written up, which was really useful and had all of the 3 key rates of the reaction, so just bear with me for a moment. Okay, so you can now see the rates of the reaction sheet over here, which I'd made some keynotes on. So these have the different key rates of the reaction questions. We have the method of this. So let me draw the diagram out. We have a conical flask, and within this conical flask, we have a liquid, so sodium carbonate in particular, also known as limestone. So we have sodium carbonate here, and what we do is then we connect this to a delivery tube. Make sure the delivery tube is not touching the bottom, and we delivery tube to be sticking into the acid. The reason why is acid will not actually get into the liquid, so we need the acid just below the delivery tube. Now we're also going to use a rubber bung to prevent any of the thing escaping, so the sodium carbonate spitting out. So we have the delivery tube, and we're now connecting this delivery tube to a much wider based beaker, and this beaker contains dilute hydrochloric acid. So we've got our sodium carbonate here, which let's represent green, and then we have our dilute hydrochloric acid, which can be represented by the colour pink. Okay. Then we're going to put a measuring cylinder upside down. So the delivery tube will be connecting through this like this, and then we'll open up onto a measuring cylinder. So this is the equipment that you'll have to set up if you were to do it this way. So what you're doing in this entire reaction is you're trying to measure whatever's coming through the sodium carbonate, so the carbon dioxide, and bubble it through the hydrochloric acid. So firstly, you need to make sure that the delivery tube does not stick in, as we said here. And then you need to make sure that the reason why it doesn't stick in, because otherwise the acid will then go up the tube, and we don't want the acid to go up the tube. We want the gases produced to go up the tube. Now, what would cause an anomalous result in this situation here is the fact where you can say the measuring cylinder is too much over the delivery tube. So so when the measuring cylinder is not completely over the delivery tube, then this could be an anomalous result here, or that the bung is not fitted correctly. Now, what could a student do to improve the results? Take more readings. Suggest one improvement that can be made to this apparatus here is the idea that using a gas as a syringe so that the gas would not dissolve in water. Or use a burette or pipette to measure the acid more accurately. So instead of a measuring cylinder, use a burette or pipette. Okay. So now I just wanted to let you guys have a bit of a break actually, because I feel like I don't want to overload you with the required practicals. But that's just one of the rates of the reaction. The other ones are here. But that's all we're going to cover today, unfortunately. I may be doing the physics paper one later on today, but because of the many practicals in this, I think I'll just make a separate video explaining the practicals in depth. So thank you so much for watching, for everyone who's been here, and wishing you all the luck, all the best in your exams. And make sure to watch that recent video of what to do with your Easter if you have wasted it, unfortunately, and things to do to improve it, because yes, you still have time. Okay, again, thank you so much for watching,